All right, so we're going to the pondering pond. Let's see what question we have over here. Oh, here's a good question, right? This one here is based on, well, pressure in fluids, which falls under the topic of hydrostatics. Anything with fluids and pressure is hydrostatics, which they said was coming for the exam. So get started, of course, send your answers across. So when we're doing the first part here, what I would do in the exam, well, I'm obviously going to write my formula like this, right? So I will put pressure is force divided by area. But having these symbols is not enough, right? You want to put what everything stands for. So you have force, and in brackets, you put Newton, so the examiner knows, hey, the force in today's question is being measured in Newtons. He stands for the area, and you want to put the units, because remember, but for this formula to work, it has to be in meters squared. It won't work with the centimeters squared. But we know P is for what? Pressure. Now, pressure, you can state it two ways. Pressure is measured in pascals or newtons per meter. Any one is correct in the exam. So this is part 3. They give you the force in newtons. It was so nice enough to give you the force, the area in what? Meters squared. So it comes like it have no tricks in this question. So pressure is just force divided by area. And you just show the examiner, you take the 480 and divide it by the 0.01, and you get 48,000 pascals, or you could put Newton meters. I don't think any examiner is going to really care which unit you put it in. All right, so we have part 3 now, right? So that is out of the way. But what about part 4? Well, what's the answer for part 4? So we know the pressure on this side here is 48,000 newtons. Now they're asking for the pressure on the other side. You notice the other side is larger. So what would be the pressure on the other side? Talika, correct. But when you're sending the answer, make sure I say part 4 so I can keep track of everything. Right? So how a liquid works, well, a fluid. The pressure in liquids does remain constant throughout. So for part 4, believe it or not, the answer is also 48,000 pascals, right? So you need to know that about fluids, right? And especially in these types of questions, the pressure, only the pressure is the same on both ends, which means for part 4, you have a new area. So you have a new area and you have what? The pressure. Isn't it really, really easy now to calculate the force? Because force is the pressure, which we do have, and the examiner was so nice to give us the area. Right? So force is pressure multiplied by area. So you just taking 48,000 and multiplying it by 0.15, and you will get 7,200 newtons. Look how easy that was. Right, so take down the working. This is going to be a permanent recording, so you don't have to worry. Guys, let's see what the prize is at this end here. What you all think about this one? This one is a keeper. All right, so you can write it down. You know what we're going to do at the end of class? We're going to try to figure out. That's all, guys. All right, so where to next, guys? That was the go ahead, I'm losing my speech here. Pondering pond. I don't think we went to the abandoned farmers yet, right? Oh, we didn't go to the haunted forests yet? Now we went to the haunted forest last week. We didn't go to the abandoned farmers yet. So let's go to the abandoned farm. And after we'll go to the sad trees. Ooh. A question on pressure, gases. All right, so the formula we want to use here is P1 multiplied by V1 on T1. This is the before situation. And of course, you have the after situation. Now, in this question, it seems to me that the pressure, sorry, the volume is remaining constant in the question. So as you all remember, whatever is remaining constant, you just cross it out on both sides of the equal sign. So it seems only pressure and temperature is going to be involved in this question. And of course, temperature for this formula to work has to be in Kelvin. We cannot work in degrees. So this 10 degrees, I think we're going to have to add 273 to it, which is how much? 283 Kelvin. So let's get to the formula here now. So we have P1 on T1. So the pressure initially is 1 multiplied by 10 to the power 6, right? Well, sir, that's not actually the before situation. The before situation is actually these two values, the 283 and the 8.5. So the pressure at the beginning was 8.5 multiplied by 10 to the power 5. The temperature in Kelvin at the beginning was 283. It will open when the pressure is 1 multiplied by 10 to the power 6. And of course, we're trying to find out that particular temperature. So I guess in your could cross multiply from here. So let's just quickly cross multiply. You'll get 8.5 multiplied by 10 to the power 5. And let's multiply these two. I need my calculator. Right. And we get 283 and how much zeros? 1, 2, 3, 4, 5, 6. Right. So we throw across the multiply and we get what? A divide. Right. Hopefully you'll get a small-ish answer here. And I'm getting roughly 332.94 Kelvin. You could state the final answer in Kelvin, like I said, or you could put it in degrees. So we can minus 273 from that. Oh, and this is why some people got 59.94 degrees Celsius. Right, so either answer is correct. It doesn't matter, right? Right, so if, I just pointing out one thing again, if you put degrees Celsius in the formula, that's 100% wrong. It must be in Kelvin inside the formula. All right, guys, so take down the working, right? Take a 20 seconds, and then we'll see what price it have in this area. All right, so let's see what's going on in this area here. How does this one sound? I kind of like this one, but I like I like gardening, so this appeals to me. Answer, you say it's a keeper of any choice, of any choice. It could be rice, it could be coconut, it could be Julie mangoes, tamarack, hot dogs, whatever you want. All right, so let's move back here. No money trees. All right, so people were asking to go to the sad trees area, right? Oh yeah, soursop real expensive. All right, so we area of the sad trees. Oh, this one is a forces questions based on moments. This one should be pretty easy. We all know that it's going to have a weight, right? So I think here's the center of gravity. So at this point, the weight is going to be acting, and there's going to be a tension in the rope here, right? That is the answer for part one. Believe it or not, it's just something simple as that. The weight acting at the center of gravity, and the rope has a tension in it. That's finished. Write two equations relating the forces. Now remember, it's pivoted over here. So there will be a moment force caused by the W, and there will be a moment force caused by the T. Right now, obviously, we don't have values for the W and T as yet because we haven't reached part 3. So in part 2, they just want you to use the letters, get expressions for each moment. Force by perpendicular distance. And then move on to part 3 and send the answer. For part 2, this is all they wanted to remember. It have two forces, right? Remember, a moment is what? Force multiplied by the perpendicular distance. So for part 2, the two equations is this. This force is W, and the distance from the pivot is 0.8. So it's W multiplied by 0.8. So the first equation is what? 0.8 W. And the next equation is what? The other force is tension, and his distance from the pivot is 1.75. So tension multiplied by 1.75, which is obviously 1.75 T. That is all they wanted. Nothing else. So I think some of you were overthinking it. And now in part 3, right? In a balanced system, in a system that's in equilibrium, clockwise movements is equal to what? Anti-clockwise movements. Well, but you want to spell it out for the examiner, right? And then, well, the W is making it spin which direction? Look at it. The W is making it fall downwards. That's a clockwise direction. And the T is kind of pulling it upwards, kind of rotating it anti-clockwise. So all they're asking you to do is put 0.8 W equal to 1.75 T. And we know the value of W. W is the weight. If the mass is 20, then the weight is how much? 200. We have to multiply by gravity. Isn't it possible to solve for T now? Well, I did the majority of the question there. So quickly solve for T and send your answer. Right, so Ariana, correct. Right, so you're just throwing across the multiply. Throwing across the multiply, you get a divide. Tension is roughly 91.43. Don't forget your units, newtons, right? Tension is a force. All right, so how much of you were overthinking this question? Because when it comes to moments question, this was one of the easier ones out there. There were only 2 moments. Sometimes they give you 3 moments and sometimes 4 moments, right? So it was just clockwise equal to anti-clockwise. All right, so let's see what the price is in this region here. All right. Cool. So let's move on here. Get some music, some effects playing here. I already can't remember this one. Let me see what I was thinking. This seems familiar, and we went here last week already. Oh, all right. Shucks. We did that one already. All right. Well, we have a second question here, and I believe we have a second prize in this same area, hopefully. All right, so here we have waves. They want to know what A to G represents. You don't have to send your answers for all. I think that would take too long to type up. So you just do from A to G on your end. Just let me know when you are finished, and then I will put down my answers, and then you could let me know, hey, how much you got correct. All right, so I think this one was pretty simple. E is the actual top of the wave, right? So you call that the crest. The distance between two similar points, right? You notice here and here, you call that the wave length, right? C is the distance from the resting position to the highest point, but that actual value is called the amplitude. D, but that's the underneath or the lowest point on the wave. So that's called the trough. I think I spelled that. I spelled that correct? Or it's TH, or it doesn't have an H in it? I just really can't remember. H or no H? No H. All right, thank you. Trough. All right. E. That's another amplitude, right? From the rest position to the lowest point. Believe it or not, that's also considered the amplitude. F, the distance between two similar points on the wave, that's a wave length. And G, but that's the resting position, right? How much of you all got all correct? Right. F is not the frequency, that's the wave length, right? Area. Let me see what I was thinking at this point. So 3 comes up again. I don't know what you all think of this one, right? But how it works now, you could ask a tree, like if somebody is in China and the next tree, that tree could send messages to all the other trees and give you info, what's going on any part of the world. But once there's a tree next to that. Yeah, this is for people who want to mind other people's business. All right, so I don't know what you all think about, I don't want to use that word, Nikki. All right, Angelo said he liked that one. Okay, all right. I don't know what I was thinking. So let's move back here. I personally won't keep this one. All right, guys, so let's visit another area. Where do you all want to visit now? Because we didn't do the question twos as yet. No, we only did the question one, the yellow questions. We still have question twos. First person to request an area. Let's go. Dead Lake. All right, Dead Lake question 2. Oh, electricity question. Electricity and heating mixed up in one. Okay. So for the first part here, right? which is, I think it's this formula you're supposed to use, right? The PIV, what I call it PIV, ever since I'm in school, like power is current by voltage, right? And well, you know what to do in the exam. Make sure and label all the symbols and whatnot. Which, no, not just a whole, I do something wrong. PIV. We have a next, just our guys. Sorry, my brain moving a little slow. They give us two things here. They give us power and they give us voltage. So isn't there another formula just now? Power is V squared on R. How much of y'all use that formula instead? Yeah, that is right. I mixed it up just now, so my brain running a little slow. So we have the voltage and we have what? The resistance. So power is voltage squared divided by resistance. Right. So, okay, some of you say you want to work it out. All right, I'll give you a few seconds, all right? So remember, you're trying to find what? Resistance, so it's V squared divided by P. So resistance is V squared divided by P. Take a few seconds, I'll give you a chance to send the answers there. All right, so Angelo, well, you didn't know it, but now you know the formula, right? So it's 120 squared divided by 100. 120 squared divided by 100. And I'm getting the resistance to be, yes, no, right. So the people who got the 14.4 ohms have it correct, right? A lot of people had 5.56 for some reasons. I tried to figure out what causing that error. Like, how come you're getting that? Some people got that answer, right? Sorry, by 1,000, sorry. I wrote 100, but I did divide it by 1,000 on my calculator. All right, so we have the resistance. The resistance is 14.4 ohms. So I'll give you some more time for the other part 2, right? All right, so let's calculate the energy here now. Now, they said the mass. Now, the mass has to be in kilograms because they gave the specific heat capacity with a kilogram in it. 4,200, and the change in temperature, I guess, is going to be 70 because they're going from 30 to 100. So the change is 70. Let's multiply that out. Let's see what's that. 0.5 by 4,200 by 70. And I get 147,000 joules. So to calculate the time, we have to take the work or energy, which we do have. That's the 147 with the 3 zeros. And then we have to divide it by what? The power, which is 1,000. If we divide those two things, the time is definitely going to be 147 seconds. Right, so congrats to the people who got that. Next on the list, this is latent heat, right? So I need to think through this question. Right, so this for latent heat, remember, energy is what? Mass by the latent heat of vaporization. Now remember, we're trying to find LV, right? That's the aim of the question. Now, they told us 100 grams of the water was converted into vapor, right? So these formulas work with what? Kilograms. So we have to divide this by 1,000. So we'll get 0.1 kilograms, and we still have to find LV. But they didn't give us the energy for this process. But remember, energy and work is the same thing. How do you calculate energy? You just have to take the power and multiply it by the time. Now, the power of the heater is 1,000. So if you take the 1,000 and we multiply it by the time, now the time has to be in seconds. So it cannot be in minutes. So we have to take that 4 and multiply it by 60. You think you can calculate LV for me now? Multiply this out and then throw across the multiply to get your divide. And it should be okay there now, right? So send that final answer. All right, so when we work this out, we get an LV as 24 and it have 5 zeros. 1, 2, 3, 4, 5 joules per kilogram. Right. So if you want to put your commas there and whatnot. All right.